Okay, so now we want to solve this question 2, which is taken from your tutorial sheet. So here you are given four pulleys are equally spaced along a shaft, and each has an out of balance mass at the same radius. The out of balance masses in the second pulley is 3 kilogram, and the third and fourth masses are 72 and 220 to 8. Determine the masses in the first, third, and fourth pulley, and also the angle of the first mass relative to the second mass if the complete balance is achieved. So this is the statement of the problem. Now we can draw a diagram for this specific case. So as you know that we have this shaft. So four pulleys are equally spaced along a shaft. So you have four pulleys here. So pulley 1 is attached here, and one pulley is attached here, for example, and then one pulley is attached here, and one pulley is attached here. So you can say that is pulley 1, pulley 2, pulley 3, and this is pulley 4. And the distance between these pulleys are the same. So this means that you can take this distance between pulley 1 and 2 is d, between 2 and 3 is d, and between 3 and 4 is also d. Uh, are equally spaced along the shaft, and each has an out of balance mass at the same radius. So this means that R1, so you can say that R1 equal R2 equal R3 uh, equal R4 equal R. So we can represent this by this R here. In addition to this, what you are given is the outer balance mass in the second pulley is 3 kilogram. So you are given M2, which is 3 kilogram. So which is the outer balance mass in pulley 2. And the third and fourth masses are at 72 and 220 to 8. And you are also given the angle uh, of 3 with respect to 2, which is 72 degrees, and you are given the angle of the fourth mass with respect to the second mass, which is 220 degrees here. So this means that it is the angle of mass 3 with respect to 2 and the angle of mass 4 with respect to 2. So we are just showing this by this symbol here. Okay, so what exactly you need to calculate? Determine the masses in the first, third, and fourth pulleys. So what you need to calculate? You need to calculate M1. You need to calculate M2 is given. You need to calculate M3, and you need to calculate M4, and also the angle of the first mass relative to the second mass, and you also need to calculate the angle of the first mass with respect to the second mass if a complete balance is achieved. So this means that if we have a dynamic balancing, okay. Now we can also draw the masses here just for convenience. So as you can see in this case, what we can do that we will draw the mass. So this is our M2. So we can draw it a particular location. The absolute position of M2 is not important. The only thing which is important is the relative position of each mass, because all these masses are rotating. So its absolute position is not important, but the relative position of each mass with respect to the other mass is important here. So if we consider that M2 is in this direction here, which is and if we consider this is our coordinate system, so this is our x axis, this is our y axis. So M2 is considered a mass in the x direction here. And now obviously you are given the angle of mass 3 with respect to 2, which is 72. So we can draw this also. So this will be our M3, and the angle here will be 72 degrees. And so this angle is 72, and this is M3, this is M2. And now you're also given the angle of this 4 with respect to 2, which is 220. So the 220 will be somewhere in this direction here, and this is our M4. And the angle which is given is this angle here, and which is 220. 220 degrees. So this means that that this angle with the horizontal should be 40 degree here. So this angle here is 40 degree. Okay, and now you're also given that R1 equal to R2 equal R3 equal R4, which is just R. So this means that that this is our R, this is also R, and this is also R. In this case, you are given M2, which is 3 kilogram, but you are not given M1, M3, and M4. These are unknown, and you even don't know about the location of the mass 1. Okay, now because we have a complete balance, a complete dynamic balance, so this means that summation of all the moments is 0, and summation of all the forces is 0. So if we take the moments about any point on this chop, it should be 0. If you take the moments about 1, about 2, about 3, about 4, it should give you 0, because it's a dynamic balancing. Or even if you take the moments from this point here, or from this point here, or from some internal point, so from all these points the moments should be 0, because it's a complete dynamic balancing. And similarly, we will have to satisfy the final condition, which is summation of all the forces, which should also be equal to 0. Okay, so now we need to calculate these unknown here. So what we can do, we will just start with the first equation here, that is summation of all the moments. And in this case, if you take moments from M1 here, so if we take the moments from location 1 equal 0, and obviously we can split this equation into two parts. One will be the summation of all the moments 1x, and summation of all the moment 1y, the same as we were doing before. So we can split this equation into two parts. So one will be the moments in the x direction equals 0, and another one will be the moments 1y equals 0. So if we take the moments, the first equation here, so this means that we will take all the x components of these forces, and we are taking the moments from 1, and then we will multiply with the distances here. So if you take the moments from location 1, so what do you have here? That in x direction we have M2, M4, and M3. So you're also given M2, which is 3 kilogram. So if you take M2, so M2 times D, and D is this distance here, and M2 is in the x direction here. So you will just take this M2, which is 3 times, and 3R is mr is the force here, and we will multiply force with the distance. So the distance here is d. So if you calculate these forces here, so the force in this direction, it will be 3r. We are doing everything for omega equal 1. This force will be equal to m3r, because we don't know m3 here, and this force will be equal to m4r, because we don't know m4 and r. So it will be just we will be representing this in terms of m4 and r, and obviously these are for omega equal 1. So for this f2 is equal to 3r, and then you multiply with this d here. Similarly for location 3, the force here is m3r, but if you are taking the x component here, so you will need to calculate its x component. So the x component of m3r will be equal to plus m3r, and it will be equal to cos 72. And the distance here, from, because we are taking the moments from this equation here, so the distance here is 2d. And now if you take the force here, which is m4r, and the x component of m4r is obviously negative, because it's in the negative x direction, so which will be minus m4r cos of 40 degree, and the distance here is d and d, so which will be 3d, equal to 0. So now if you look at this equation here, you can cancel d, because d is everywhere, and you can also cancel r, because r is everywhere. So from here what you will get, 3 here, you will get 2 m3 cos 72, and you will get minus 3 m4 cos 40 equal to 0. So this means that this is just one equation here. Now if you take the second condition, which is summation of all the moments 1y equals 0, so now we are taking the moments of all the forces which are in the y direction. So if we take the moments of all these forces, which we can calculate from this figure here, so and again we are taking the moments from this one point here. So for the m2, there is no force here in the y direction. The whole force is in the x direction, so the y component is 0, so you don't need to worry about this one. For the m3, you need to calculate the y component of this, which will be equal to m3 sine of 72, and this will be positive because it's in the positive y direction, and the distance here is for the m3 is 2d here. And then for m4, again you will need to calculate the y component of m4r. So it's again in the negative y direction, so minus m4r sine of 40, and the distance here is d, so it will be 3d equal to 0 here. So if you just simplify this equation, So as you know that D is here and here, so you can cancel D. Uh, Obviously we have R here, so you can cancel R and R. So what you will get here, you will get 2 times M3 sine of 72, and this will become minus 3M4 sine of 40 uh, equal to 0 here, and this is our equation 2. So now if we look at the equation 1 and equation 2, so this is our equation 1 and this is our equation 2 here. Now you have these two equations, and in these two equations we have two unknowns. So one is M3 and one is M4. So two equations and two unknown. So if we solve A and B, so 1 and 2, so solving equation 1 and equation 2 simultaneously. So what we will get M3 equal to, so you can do this yourself, this kilogram, and you will get M4, which will be 1.8 kilogram. So we managed to calculate these two terms, which is M3 and M4. Now after doing this, now we need to calculate M1 and theta 1 2. So now the second part is that we now need to calculate this this M1 and theta 1 with respect to 2. Now obviously we don't know the exact location of the mass M1. So what we can do, that we will just assume that mass M1 is again somewhere here. So this is our M1, and this will be the angle that this mass will be making with the horizontal, and obviously this R is given, which is R. So now for this case, we will be just using the condition of that summation of all the forces equal to 0, and we can use both condition in x and y direction. So if you use this condition, that summation of all the forces in x direction equal to 0, so you will collect all the forces in x direction. So you have the all these forces here. So in x direction, we have this M2R, which is 3R, and it is in the positive x direction. So 3R is the force. Now we are not taking the moment, so we are not multiplying with the distance. So it is just 3R, which is the and again it is for omega equal to 1. So 3R is in the positive x direction, so therefore it's positive. And in addition to this, now we can write the x component of this second force, which is M3R. So which will be M3R and cos of 72. And then for this force, the x component is negative, so minus M4R cos of 40. And then we will also need to add the contribution of M1 here. So we are taking this is positive, so this means that the x component is in this direction and the y component is in this direction here. So if you add the x component, which will be M1R is the force and cos of this theta, and this is our theta 1 here, so you can call it theta 1, and they should be equal to 0. So you have this this equation here now, So if you look at this equation, r is everywhere, so you can cancel r from this equation. So what we will get, that we will get 3 plus, you know, m3 now. You already calculated its value, which is 1.82. So 1.82 cos of 72. And then you also know m4, which you already calculated in the previous case, which is again 1.8. 40. And then m1 is unknown, and the angle is also unknown, so we will just put it there. So if you just try to simplify this equation here, so what you will get, m1 cos theta 1, this will become minus 2.1835. So if you call this equation equation 3, so in this equation, this is a one equation and there are two unknowns, so we cannot solve this equation. So now we need one more equations which we can get if we use this condition here, that summation of all the forces in y direction equals 0. So if you use this condition here, now we know that for the m2, it's in x direction, so the y component is 0. For the force in 3 direction, we have the for the third direction we have m3. So which is 1.82 and sine of 72, so which is the y component of this this force here, and m4 is 1.8, so and it's the y component is negative, so minus 1.8 sine of 40 degree, and then you will add the contribution of this m1. m1r and sine theta 1, and that should be equal to 0. Now obviously in this case we know that r is everywhere, so we can cancel r. So the final equation in this case which we gonna get is m1 sine theta 1, and that will become equal to minus 0.5 739. So this is our equation 4. So now you have two equations. So one is equation 3 and one is equation 4. So one is m1 cos theta 1, one is m1 sine theta 1. So this means that that we assume that the mass is actually in the first quadrant. But if you look at this equation here, so in this equation the x component of the mass, and which is, if you multiply with the r, so this is actually the force is actually in the negative direction, and this is also negative, so this means that we are somewhere here. So if you draw this, so this means that the x component is this one, so which is 2.1835, and the y component is in this direction here, so which is 0.5739, and we can draw the resultant which is should be in this direction here. So as you can see in this case, you have m1 cos theta 1 and m1 sine theta 1. So from this equation, what you can do, that you can calculate, if you just divide d, or which is this equation here. So if you divide equation 4 by equation 3, so if you divide equation 4 by equation 3. So what you will get m1 sine theta 1 divided by m1 cos theta 1, and on this side what you will get is uh, 739, and here you will get minus 2.1835. So from here you will get tangent theta, because the mass will get cancelled. So you will get tangent theta 1, which will be some value here. So then you can calculate theta 1 by using the tangent inverse, and in this case it is 14.72. So this means that this angle, which is which you can call is alpha. So this alpha is actually is 14.72, which is this alpha here. But actually we need to calculate this angle with respect to this mass m2. So we actually need to calculate this angle here. So the theta 1 should be equal to 180 plus alpha, and in this case it will be equal to uh, 180 plus 14.72, so which will be about 195 degrees. And if you have this angle now, so now you can put this angle back here, and then you can calculate in for example in one of the equation. If you take equation number 3, for example, or so equation 3, then you can now calculate mass m1, which will be equal to 2.2577 kilogram. So in this case we were required to calculate this angle of this m1 with respect to the mass 2 here. So this was our mass 2, and our mass 1 is actually in this direction here. So this is how the angle will work here. So you can calculate this angle, which in this case is just alpha will be this angle here. But if you want to calculate it with respect to the m2, so it will be you will need to add this 180 with it, and then you can put this theta in one of the equation, either in equation 3 or 4, and then you will get m1.